welcome to, let's see, the day before, the only day of school on this week, right? So,
Yeah, why are we here again? Except none of us have a test tomorrow.
ooh,
I know.
is it anatomy physiology?
I haven't even looked at the study guide yet.
Oh, it's, that's not good.
I did this for the last one.
Wow. Okay. Until after tomorrow. Unless you like anatomy. So let's. That's funny. All right, class. Let's go with it here. So function. Let's go definition of fit first. Can we yell anybody at the door? No. Okay.
Well, it was my dad.
Okay. Let's go with it here. Quick story. So let's say we built ourselves a wave runner, and wave runner that looks like this, maybe.
For those of you who don't know the term, it's seated.
Oh, thank you so much. And so let's say we're testing it on the waves. So that's a little wave tester. We good? And so we test, and we're trying to look at how fast the engine is working compared to how fast it's going on the water. We good? And RPMs are usually measured in, it's called rotations per minute, how fast it's cycling through. And so when an engine is barely cycling through, usually we're running at 1,000 RPM right here. And then you can get up to like 8,000 RPM if you wanted to here. So that's 1,000, 2,000, 3,000, 4, 5, 6, 7. Let's go 8. Okay. And so then we have speed. Speed is going to go with maybe 10, 20, 30, 40, 50, 60 miles an hour. We good? Here's our. So if you want to draw it out, that's fine. This is kind of just a little story, just sort of think about it, and then we'll define our terms. We good? So don't really need to write it down if you guys don't need to. Just kind of let's pay attention here. So let's say this here. I start the motor. It's on 1,000 RPM, just barely functioning, no gas. Right. This is just, and then I have a little dot right here. It's just barely moving across the water. So at 2,000 RPM, it's here. 3, 4, 5, 6, and then that's off the chart at this point. Okay, does this all make sense though? Right? It makes sense, right? Would it make sense if I had something like this? So I'm going to do this one, and then I have this.
It disappeared.
Well, it disappeared. It doesn't see it. It doesn't make sense, so it disappears. Would that make sense? We're testing a wave runner, and we went up to 3,000 RPM, and I'm thinking that does not make sense, correct? You can't have something that's traveling two different speeds at the same time. Okay, so welcome to functions. That is exactly what this is. We're trying to figure out in an abstract way what makes sense in mathematics as far as a graph is concerned and what doesn't here. So one thing is notice on the previous one, if I did it like this, if we were to pass something called vertical lines, if we pass vertical lines down like this, notice we say something called, this passes the vertical line test. It doesn't hit any of these dots more than once. We good? When it hits to here, though, when it hits this little dot right here, are we in trouble? Yeah, it's hitting a dot that's two different dots, right, for the same x, and that's our little problem right there. So let's define what a function is, and then let's jam from there. Boom. So definitions. Now I've got to write it down. And then we'll make a little, so this is the long writing down here. Definition of function. Oh boy, here we go. A function, we'll call it f for function. From set A to set B. That's what we're looking at. Is a relation assigns to each x in A only one y in B. And so that's the little definition of function right here. And chicken scratch here. So function f from set A to set B is a relation that assigns to each x in A only one y in B. So I could have changed the x's and the y's as well. But does that make sense? Does that make sense with the wave runner story as well, right? You can't have two things. You can't have two y values for the same x value. It would not make sense. So then let's do this here. Let's divide this out. You guys tell me which one of these guys are functions or not functions. We're good? We have a set A, a set B, and we have different things here. And so let's say this x or this dot goes to this dot here. This dot goes to this dot over here. And let's do three of them here. Go, go, go. Okay, the other relationship is A to B. And the third part. Today's picture day. Is that right? When is it happening? House. Like right after school?
No, it's
So they changed
every
up the
class
periods.
except for this one got 10 minutes chopped off and lunch is shorter, so there's an hour left.
Perfect. Okay. Cool.
The last period had 2:30.
Gotcha. So every single period except for this one is 10 minutes shorter, right? To accommodate
Zero
for.
period was also the same length, but zero period.
Yeah, 0 period not counted. All right, class, let's go for it here. So can I pick on people here? Let me start out with this one. Going this way here. So Isabel, the first one, function or not a function? Function, absolutely. One every single element A goes to element B. Landon, all yours. The middle one, function, not a function. Okay, so think back to the wave runner story, right? I have these three little dots. Boom, boom, boom. Going to these three little dots here. So this one says I go to this one. This one says I go to the same one. This one says I go to a different one. That is a function, right? You can have the x go to the same y. It just means the wave runner wasn't going faster. We increased our RPMs with the friction of the water, with the way the motor's made. It didn't go any faster. That was it. All right, and Tristan, last one, yes or no? This is our problem right here. It's this little piece right there. You can't have the x go to two different y's. That does not make sense as far as functions are concerned. Okay, so let me show you. So there's that way to see them. So this one would be a yes. This would be a yes. And this would be the no. It's the x that's repeating itself that's going to a different y. That's our little issue here. All right, so let's see how we're going to see it in the book itself here. So exercise 1, let's jam. Exercise 1, state if it is a function. -1,12736. Alright, so I'm going to set 3 problems here in a row. All yours there. Should do D as well. So one more for D. I'm going to 1, 2. 2, 2, and 4, 5. There it is, 4 problems. So we're going to go with the yes or no on each one of those here. This probably takes longer to write out the problems than actually do the answer. And we go from there. All right, good. Copying down the problems themselves. Let's keep on going. Oh, and all yours, yes or no for A?
Yes.
It is a function. And that, all yours for B?
No.
A tricky one. This is a tricky one. I should have given Owen the tricky one just for the fun of it. So Annette says no. Let's do a class vote. Class votes. How many say yes? This is a function, Mr. Hendry?
That's mine is the same.
Yeah, that's it. How many say it's not a function? Okay. Yeah. So notice the x's repeat themselves, but they're going to the same exact y, right? So there's no new information. So there's no second dot, right? That's actually in there somewhere. So yes, that is a function. So Annette tried to trick you. You still figured it out. That's cool. Dylan, all yours for C. Yes or no? No. How come is? Yeah, it's this little part right here. Here's our little problem. The one of the x's is going to a 2, and the one of the x's is going to a 3. Not cool, not cool. There's our problem. And Charlie, D, all yours, yes or no? I'll go with the yes. Notice it's not, we're concerned with the x's repeating themselves. The y's can repeat themselves for as long as we like. It just means the wave runner wasn't going any faster, but we still changed our RPMs. Okay, that's cool. So there's look at functions through just dots themselves. We good? So let's take a look at functions through formulas. So equations here. Exercise 2. State, same directions here. If it is a function, same exact directions, a little bit different take on things here. Okay, so last one was just ordinary points themselves, right? We switch on to go to equations themselves. So with equations in mind, is this a function? So keep in mind is we're kind of thinking through this here. If I put in x values, well, there'll be multiple x values for the same y value. That's kind of what I'm thinking. So almost like you work backwards on it here a little bit here. If I put an x value, well, I get 2 or 3 or 4 different y values. And I'm going to go with, let's see. Notice if we solve for y, if I just subtract x from both sides like this, kind of think to ourselves here. If I put in a single value for x, do I get out only one value for y? So let's say this is like a 1 in here. If I put a 1 in there, boom. If I get myself, what, a 2 out of it? Is that right? I put a 2 in there, I get myself a 1. I put a 10 in there, I get myself a -7. So notice for every single x, I just get one single y out of it. Good? So yes, this is a function. Let's see where things get all goofy just a bit here. How about this? How about if I put a square in for the x value? So now it's x squared plus y equals 3. Is this a function?
No.
So I'm thinking as soon as I plug in an x, I do the computation, and it spits me a single y value. If it does that, it's a function. If I put an x in there, and it gives me like 2 or 3 values for y, then it's not a function. So I guess we got to solve for y first. So subtract x squared from both sides. Y is equal to -x squared plus 3. So here it is, the test. Ready? I plug in x value into here. Again, plug in a 1 or so, right? I plug in a 1. 1 squared is 1. It's a -1 plus 3 is a 2. Okay. I plug in a 2 into there. 2 squared is 4. A -4 there. -4 plus 3. -1. We good? But notice for every single x value, I just get out one y value out of it. So yes, this is still a function. C is where we want to get to. So let me change it up. I'm going to go like this now. Can you guys solve for y? See, I'm going to subtract x from both sides. Is that right? I give myself a y squared is equal to -x plus 3. And talk to me from algebra 1. What do we do to solve for y right here? Square root both sides. That's perfect. Hey, boom. And then I put a little plus or minus here, don't I? Because whenever I do the square root, I have to put a plus or minus. Okay, and I got myself something that looks like this in my hands. And that,
Is it okay if there's a negative under the square root? It's part of like a Weiser equation?
yes, Because now we can fill in different values for x. So if x is like 10, it doesn't work, right? Because 10, that'll be -10 plus 3 is -7. But if x is 1, that still works. So it'll be just the square root of 2. Right, I put this in, I never looked it up. Okay, guys, talk to me here. Is this a function? Perfect. It's this little piece right here. That's our problem. It's this plus and minus. So if I plug in a, I don't know, a -1, -1 of 1 is 1, 1 plus 3 is 4. So if I take out a square root of 4 out of this, it'll give me a 2 and a -2, and that's our problem. Okay, so it's really this little squares on the y's. That's what we're kind of careful for whenever we have these things. Okay, let's do one more. Let's do this. So this is a no. No, because of that little plus and minus thing right there. How about this little piece here? I guess we should. Yeah, let's do this. Well, is that a function? If I just take absolute value of x. Everybody? Agree? Okay, so if I put a 3 into x, it spits out a 3. If I put a -3 into x, it spits out a positive 3. I still get just 1-for-1 relationship, right? So that's still a yes. Okay. How about this one? I'm going to put the absolute value on the other side.
So now there's two answers next to me, right?
I think so, yeah. So for So if we do it in terms of just those numbers themselves, right? If I had a x is equal to 2, it could be a positive 2 for the y, it could be a negative 2 for the y. Notice the x is going to 2 different 2's at this point. So it doesn't know. So what are we careful for? Careful for even powers on the y. And careful for absolute value around the y value. That's the two things we're careful for. It's okay. Bam. So we got ourselves what are functions. And let's jam with now, how do we write them? How do we write functions? How do we do the notation? So this is called function notation. All right, so we normally name functions with the letter F, because for functions, it's totally convenient. So here it is. And then what we do right afterwards, we tell you what the variable is. So this is the variable that I'm working with, is x. And then there's the condition. We'll call this the condition. There it is. So this variable has to match with this variable. And this guy is the name of the function. So this is the f function. We can have as many names for functions as we like. So I can name another function, we'll just call it g. G of x is, I don't know, 2 over 3x squared. There is a function there. We good there? So the name of the function is g. The variable is still x, and then there's the conditional statement. So x can be changed as well. I don't need to have that. I can have h. H of m. And I can set up a little relationship this way here. So 1 half m squared plus pi m. That's cool. Name. So these are all the names. And so as many letters as I like or have, and we can have lowercase letters that are different from uppercase letters. And those are two different things as well. So C, usually, like if you write a lowercase c, that usually stands for circumference. A capital C usually is in business and to talk about cost for things. Cool, are we good there? Boom. All right. So let's go with it. I'm going to give you guys some functions here. Let's see if we can put them together here. So 1, 2, this is 3 now, right? Exercise 3. And we usually call it evaluate the function. All right, so I'm gonna set up some functions here. I'm gonna go, this one would be the easy one. I'm gonna set up f(x). G of x would be, let's give it a different value. Let's go, bless you. Let's go, t is fine, that's fine. T squared minus 2t. And h of x, give it a little funky one here. How about pi x squared? Ooh, pi x squared. Pi r squared. Ever heard of pi r squared before? This is pi x squared. So this h is really technically just area of a circle anyways, right? Different variable, still the same. So let's jam with it here. I need to know what is f of 0. Then I need to know what is g of negative 1. Then I need to know what is c of 4. All right, so notice the name of the function, right? That little name in front, that little letter in front tells me which function I'm going to use, just like each of you guys have names, right? And so functions have names themselves. So let's go with it. So this guy tells me I'm going to use the f function, and in this case, I just need to plug in a 0. So as I plug in a 0, 3 times 0 is 0, minus 5 is -5. Are we good there? This this little guy right here. So this little 0 determines that to be the 0. It is, so the function, the setup is here. The variable is set up already, right? So, but I choose the 0. So, and the book will say f of 1. Find me f of 1. Let's see if they choose any fun stuff here. Oh, they do choose some fun stuff, so we'll do some fun stuff in a second. So all yours, g of -1, and then h of 4. All yours, go for it. And I can throw in some decimals into here. I can put in an absolute value. We should do this one. We should do the piecewise function. That'd be good. All right, B and C, all yours. Then you just walk around and see how you guys do it. H of x is pi x squared. Pi x. So that's all finishing up the h value here. Boom. I'm gonna plug it in. Most of you guys finished B already here. So -1 gets plugged in. Looks like that. And -1 times -1, that little piece is just gonna become 1. And -2 times -1. 2, I get an answer of 3. Are we good with 3? Ding, ding, ding. Awesome. And then 4, this should be pi. And there's a 4 there, and then there's a 2. I usually like to put parentheses. Whenever I'm plugging in numbers, I always just have a parenthesis. It knows exactly what I'm plugging in, so I know exactly what I did there. So 4 times 4 is 16. And we usually write the coefficient first before any irrational numbers here. So 16 pi is the next one. Okay. The fun part. I guess I should write it down here. D. D, I'm going to say f of x plus 2. Whoa. That's craziness. Here, hopefully you can see on the bottom. Tristan, all yours?
H is 4 and it's pi x squared. Minus pi.
Let's say it, just so I know what you're saying.
So it's h parentheses x equals n x squared.
It should be pi. Sorry, that should be all pi.
Pi x squared. So how does x equal?
Sure. So I wrote this in right here, right? So I want to know what is h of 4. That's what I want to know. And so then the 4 gets plugged into that little piece right here. So the 4 gets plugged in for the x, and then you do whatever you need to do to the x. In this case, we're going to square it. Okay, D is the fun one. This is f of x plus 2. So I have a variable that's actually inside another variable. What? Crazy. So the x now has become x plus 2. And I usually kind of just psych students out a little bit here. Oh, when did it psych you out? No. A little bit. Okay, cool. Got a little bit of a psych out. That's cool. Okay, so what we do, this little x right here is going to change into x plus 2. That's it. So we're going to put the parentheses in. X plus 2 is what we plug in minus the 5. Notice things will change slightly. The variable is still there, but we changed it to plus 2. When do we do this? Whenever we try to adjust our variables to compensate for something. So let's say we've been dealing with degrees, right, of how hot something was, right? And so, okay, we need to up all these by 2 in order to compensate for something. That's kind of what we do. Okay, let's do it here. Simplifying this out, so we're going to multiply the 3 in. That's 3x plus 6 minus 5, and eventually it's 3x plus 1. Are we good with the 3x plus 1? Right, good. Camille, good. Sweet. Okay. So there's notation. This is how we handle notation. Let's do one more. It's kind of like a funky problem here. It's called a piecewise function. And sometimes what we do is we have functions that go a certain way for a certain amount of time, and then we change it up and we do something different. Maybe a good example would be, don't need to write this down, but like cell phone service would be a good example. Notice that whenever, let's see, it used to be that you can have so many minutes free, right? And then you have that, right? But nowadays, it's unlimited minutes all the time, right? And then usually your data is the one that's the problem here, right? So maybe up to 7 or 8, let's see, 10 gigs. You have a flat fee for your cell phone service, right? And then after that, then they start charging you per piece, right? Per one. So notice sometimes it's like this. Usually goes up like that fast, isn't it? Because it's charging you per megabyte usage. You're like, what? Let's see, my brother-in-law, I think, one time he had $1,015 bill. Like, oh, man, have fun. He was on the road all the time and didn't even think about using it. So there it is. It goes up that fast. Okay, what happens though? Sometimes, so notice up to here. So we say, look, if x is less than 10 gigabytes, right? It's this function. But as soon as it hits that 10, anything above 10, it's going to be that function. Okay? So we kind of separate two different functions of each other. Then there's another one called the step function, which is kind of cool. Just real quick here. Instead of doing like this, what cell phone companies started doing is for, let's see, up to 10, it's the same, right? It's up to here, right? But then it's like, I'm going to charge you $20 for every other gigabyte used, right? So then it goes like this. Then it's 11, 12. So it goes up to here, and then it goes like this, right? For that area of time, not per single megabyte usage, right? But for each gigabyte, you go up by a certain amount. So this is called a step function. And you kind of go like this. See the little steps in it, right? So that's another little piece there. Okay, so back to piecewise function. Let's do this here. How are we going to do this? Exercise. What are we on? We've got 10 minutes to go, so I better hurry up here. 4. I'm going to do this here. So f of x. Here's my function. My defined function is like this. It looks crazy. There's these squigglies. We call them braces. And here's my function. It's x squared plus 3 if x is less than or equal to 0. It is x if x is between 0 and 4. And it's just 13 if x is greater than or equal to 4. So we got 3 different functions happening here. They could be anything. So if it's a negative number, we use the top function. If the x is between 0 and 4, we use the middle one. And if it's 4 or greater, then we're just gonna, the answer is just 13. That's it. All right, 10 minutes to go. Let's go forward here. This is going to be f of negative 1, f of 3. Ooh, let's do a 4. Actually, I should do this one here, and then I should do f of c. D would be f of 0, and E would be f of 357. Maybe. Yeah. And it's right on the border, right? So you got to figure which one. So these little equal signs become very important. So this equal sign, so I'm using that one right at that moment here. Okay, got 1, 2, 2 more pieces we've got to sort of put together here. So let's go for it here. So -1. Which function we're going to use? Top, middle, or bottom? Top function. It's a -1 here, so x is less than negative. So -1 goes in here, gets squared. That's 1, and 1 plus 3 is 4. Done. F of 3. Which middle? Which? You can't answer. That's no fun. Middle one. Because the input value is between 0 and 4. That means we're going to use the input value, and the output is exactly what you put in. So it's just x. So whatever you put in is x, you get out as x. Now here's the tough part. F of 4. So now you got to think about which one am I going to use, and these guys become very important because the bottom function says if it's equal to 4, we're going to use the bottom function. So answer. I'll go 13. Are we good? So f of 0, for 0, which function would you use? Top, middle, bottom? Still the top, because it's x is less than or equal to 0. So in this case, the answer is 3. And the fun one, f of 357, answer is? Still 13. We have to use this function right here, because x is greater than 4, but the answer is just 13. Okay, are we good?
357 is 13.
Uh-huh.
So it's after 4.
No.
At 4.
Yeah, it's because x is greater than or equal to 4. We just use this function here. Good? Does that make sense? Okay, are we good there? Boom. So let's do two more things we've got to do. So instead of plugging in values, sometimes what we do is we set the f of x equal to values here. So what example are we on again?
We're on
5. This would be 5. Making sure. Okay. Boom. And we're racing against the clock here a little bit here. So let's jam with 8 minutes to go. I have this. F of x is equal to 5x plus 1. That'd be an easy one to do. Boom. And I need to know this. Okay, so we're going to try to finish up here. 7 minutes.
So how much is 5x plus 1?
Yep, So my f of x is 5x plus 1. And then I'm trying to find this. So notice it's not plugging in. It's not f of 0. It's f of x equals to 0. So in this case, the 0 is on the outside of it, and we're trying to make it equal to. Okay, so in that case, what we do is do this. Notice that these two are exactly the same thing, right? If that's true, I can substitute f of x or I can substitute 0. Those mean the same exact thing. So in this case, this guy turns into a 0, and I'm solving this little equation right here from algebra 1. There it is. I think we know how to solve that from algebra 1. So I could write when is f of x is equal to 5, right? When is this function equal to 17? On submarines, nuclear submarines, when is f of x equal to 225? Because that's when everything explodes, and we don't want that to happen. So we keep that temperature a little lower than that. So that maybe that even carries the sun.
Yes.
Let's get a submarine.
Don't encourage.
No? Okay,
No,
sorry.
no, see,
Don't.
because then it's sun. You can't explode. No, how do you like that? She's like, I wrote my song, so it's like, and she has to write a surprise.
Okay, are we good there? X is equal to negative 1/5. So we actually solve it as an equation. Are we good there? Did you guys solve it already? Sweet. Okay, 5 minutes to go. 2 more things to cover here. So let's jam with that is there. That's when f of x equals to a certain number. And then exercise 6 is when this happens. Sometimes it's not just a different number. Sometimes we're trying to figure out when. I think we do this here. Okay, we'll do the same one as the homework here. So I got 2 different functions. So Sometimes not just equal to a certain number. Sometimes we want to figure out when one equation is equal to another equation. In this case, it'd probably be, we have an equation for the rotation of the moon, right? We also have the path rotation for our spaceship, and so we want to know when those two are going to meet, and so that's important. Or else the spaceship goes out into space, and that's about it. That would not be good. So when do two functions equal each other? That's what we want to know. All right, so we do exactly what it says right here. We're going to set this guy equal to this guy. All right, and then this involves some work that we learned in Appendix A. Remember that guy? I think we learned how to solve these type of questions. So subtract 3x from both sides. Subtract 3 as well. That becomes a 0. And I ask myself, can I factor? And if I can't, quadratic formula. Is that right? Factoring or quadratic formula. So can I factor? I heard a yes. I'm going to go with it here. Two numbers multiplying to -2, add to -1. Say it again. Plus 1. Perfect. So a positive, -2 and a positive 1, right? Oh, cool. And the short way is we just take opposites, don't we? To solve. So boom, I take this down. X is equal to 2. Boom. X is equal to -1. There are my two answers right there. Sweet. Okay, with a minute, with 4 minutes to go. Clicking on this. Clicking on this. Sorry, going a little fast here. Tell me if you need to slow down. And then we talk about something called domain. Very important here in mathematics. Domain of a function. A domain just means when do we get numbers out. So if you can't get any numbers out, you don't have yourself a domain. Let's go through this kind of quickly here. So exercise 6, I believe, is that right? 7. It just says find the domain. And let me just go each one really quick here. So first things first. Our issues with domain are going to be these two issues right here, real quickly. It's going to be the problems with domain are fractions and square roots. That's our issues. Because with fractions, what can you not have on the bottom of a fraction? 0. Can't have a 0. That's our problem. For square roots, we can't have square root of negative numbers. That's it. Beyond those two, we're good. So does this have a fraction? Does this have a square root? So if it doesn't, then the domain is from -infinity to positive infinity. Everything works. Everything is working just fine. See how they want us to write it, because there's two different ways to write domain. Okay, B. Let's go with it here. F of x. Let's name it differently. Let's go g of x, just to be funny different. I'm going to go with 1 over x plus 4. Do we have ourselves a little problem? Yeah. -4 is not going to work here, huh? -4 is going to be ourselves a little problem. So one of two different ways to write it. You can go like this. All the numbers from -infinity work all the way up to -4. And then at -4, there's a break. Anything above +4 works just fine. We good? Or anything above -4 works just fine. It's that little -4 that's the problem. So another way to write it is just like this. You say all real numbers except x is equal to -4. There's another way to write it like that. Okay, and with a minute left, I'm going to do C right over here. C is a square root function here. So let's go with f, g, h. I'll go with h. And can I change my variable? I'm going to name my variable z, just for the fun of it. Kind of fun. z minus 10 is my function. So real quick here, oh, and which numbers will work and which numbers won't?
Let's see. 10 or higher will work, but anything below 10 will give you a negative number inside the radical.
Perfect, yeah. Okay, so let's do this here. If we wanted to solve this right here by an equation, we just say, look, when does x plus 4 give me a 0? And by solving it, we just found out that's the case right there. Very good. When we look for this one, we say, when does z minus 10 going to be greater than or equal to 0? So it's an inequality now. One's an equal sign, one's an equation, one's an equality, and Owen said it right. Any values of z that are going to be greater than or equal to 10. So how do we write this? Oh, remember those little brackets that we used? Bracket 10. There's our little way to write it. Okay, we're good, and we're 25 seconds over. So you guys are at it here. Okay, so pictures today, don't forget that. Homework is due tomorrow, and you are on vacation until next week, Monday. See you later.